Welcome to Chapter 3, Central Tendency. So the data that we're going to be working with for this lecture is right here. So imagine we collected satisfaction with life scores from 28, so n equals 28 participants. Okay. So they filled out a measure, a 5-question measure, and each question they indicated to what degree they agreed with the statement. Okay. At that point, we then took an average of all their responses. Higher scores mean higher satisfaction with life. Lower scores mean lower satisfaction with life. If you would like to take that measure, I've posted a copy of it on Canvas under Files, Week 2, by hand, and lecture. So if you want, go ahead and pause this, pop over there, take the 5-question scale, take the average of your scores, and then you'll figure out what satisfaction with life score you would have. So these are our data. And like I said, we're talking about central tendency today. So let's do this. Let's go back to chapter 1 and see where we're at in the journey. So I indicated that there are 2 types of statistics. The first type is descriptive, and there's 2 types of descriptive statistics. Central tendency and variability. And somewhere in here, I'm going to stick frequency, which is what we talked about chapter 2. Because, when we know the frequency, we can easily determine a measure of central tendency called the mode, which I believe we mentioned last time. We're going to go over it again. It helps us understand central tendency being of a distribution of data, what value is the most typical. And it helps us understand variability. Variability just has to do with how spread out are the scores, right? So if you took the satisfaction with life scale, you might have noticed that it was on a Likert scale of 1 to 7. 1 being the lowest, and I'd strongly disagree, 7 being the highest. Okay? If you take an average, so if someone scores really low on satisfaction with life, that means they put 1 for every question. Now, if you take the average of 1 for every question, it would be 1 plus 1 plus 1 plus 1 plus 1 divided by 5 is going to be 1, right? So if someone scored really high in satisfaction with life, okay, so they put 7, 7, 7, 7, 7, so 5 7s, so that'd be 35 divided by 5, they would score a 7. So it turns out on this satisfaction with life measure, the highest possible score is a 7, and the lowest possible score is a 1. Okay. So frequency will help you see the variability or the spread of the distribution, right? Because it's very possible that everyone in the distribution scored maybe 5 to 7, which would be really high satisfaction with life. Or maybe in the distribution of data, which is kind of what it's looking like here, some people score low, your ones, your 1 point somethings are pretty small, your 3s are still small, your 4s are in the middle, and then 5s, 6s, and 7s are really high satisfaction with life. Okay, so that's how frequency helps us understand central tendency and variability. But beyond frequency, central tendency has some measures that we're going to talk about today. And some of those measures include We're going to talk about the mean. Okay? We're going to talk about the median, which is also known as Q2. We're going to talk about Q1 and Q3. And it'll make more sense to you as we go on. So Q2 or median, Q1, which is the first quartile, Q3, which is the third quartile. So we're going to define all those. It's going to make a whole lot of sense, and you'll like them a lot. And then, of course, another measure of central tendency is the mode. Okay. Variability, which we're going to talk about in chapter 4, has some of its own measures as well, including range, and I'm writing IQR. IQR means interquartile range. Okay. As well as standard deviation, and then the square of the standard deviation, which is the variance. Okay, cool. So we're going to get into variability in chapter 4. So obviously right now we're talking about chapter 3, which is central tendency. So let's get into it. But before we do, I want to complete this. I said there's two types of statistics. One's descriptive. The second type is inferential. And inferential is huge. Have you heard of t-test? Have you heard of ANOVA? We'll get into that. Simply what you're doing is inferential statistics allows you to make a statement about the population based on sample data that you collect. So it's really powerful. But we'll get to that later. But at least now you know. So I'm going to go ahead and erase this, and then we're going to go move on and talk about central tendency more. We'll talk about the mean, the Q1, Q2, Q3, mode, and others. Okay, so the first thing we're going to learn about is the mean. Okay, and what's the mean? The mean is the sum of x divided by n. Okay, the sum of x. When we talk about x, we talk about raw scores. Okay, these are raw scores. So the sum of x means we're literally adding all of these numbers together. So go ahead and add all of these numbers together. Okay, so 1.4 plus 1.6 plus 3.4 plus 3.6 all the way to 7. And you'll find that you get 140. Okay? Now what's n? N is here. N means how many subjects or how many participants were involved in the study. So there's 28. So 140 divided by 28 equals 5. So the mean of this distribution of satisfaction with life scores is 5. Let me write a formal interpretation. On your exam, I'm going to require you to write formal interpretations for everything. something like this. The average value in this distribution of satisfaction with life scores is 5. Okay? Remember, central tendency is talking about the most typical score. So when asked, what's the most typical score in your distribution of data? Right here, you could say 5. Which then, if it equates to people having a tendency to be satisfied with life. If you consider 4 the middle point, right? Because they can score highest 7, lowest 1. Okay, good. So now we're going to talk about the median. Okay, so the median, as you can see, it's also called Q2 or the second quartile or the 50th percentile, which I believe is the most informative name. So the equation for the position of the median is 0.5 multiplied by n plus 1. 0.5 multiplied by n. Our n we determined was 28 plus 1. Okay. 0.5 multiplied by 29 is going to give us 14.5th position. So this is important, so listen well, okay? This equation gives you the position of the median, okay? It doesn't tell you what the actual median is. So in order to determine the median, you have to do what I did here. You have to first order your data from smallest to largest, okay, which is what I did here, okay? So we wouldn't have to do it in this video because that would be tedious. So order your data from smallest to largest and then count. Find the 14.5th position. So how do we do that? We start at the lowest number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14.5. Okay, so 5.4 is the 14th position. And 5.4 is the 15th position. So our median is the number between those. Okay, so I'm going to show you a foolproof way, a foolproof way of always figuring out the exact number. Okay? So here's the foolproof method. Here, let me change colors. So what you can do is you could say, okay, cool. What's the difference between 5.4 and 5.4? So essentially you're asking yourself, what's the difference between the smaller position, right? So 14.5, in that case the smaller position is 14 and the larger position, which is 15. And in this case we find the difference is 0. Okay, that's the difference. Now what you do to figure out the number that's in between is you multiply this difference by 0.5. In this case, it's going to be easy because anything multiplied by 0 is going to be 0. Okay? So then what you do is you go back to the smaller position, which in this case is the 14th position, okay? And you add whatever you got here, which in this case is 0. So the 14.5th position is going to be what? Okay, it's going to be 5.4. Okay. So why is it important that this is called the 50th percentile? Okay. Well, it's part of the interpretation. So here's your interpretation for median. 50% of the scores in the distribution of data are lower than 5.4, which is the median, and 50% are higher than 5.4. Okay? So we determined that our median is this 5.4 value in between the 14th position and the 15th position. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 of the scores are below the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 of the scores are above the median. Right? There you go. 50% are above, 50% are below. So there's your interpretation for median. So the next thing we're going to talk about is the Q1. The Q1, also known as the first quartile or the 25th percentile. So the equation to find the position of the first quartile is 0.25 multiplied by n. 0.25 multiplied by n, which is 28, is going to give you the 7th position. Okay, so this is not going to be too difficult. Again, the values in the distribution of data have to be ordered from smallest to largest. Okay? And then you start from the smallest value and count. 1, 2, 3, 4, 5, 6, 7. Okay? So it looks like your Q1 is going to be 4.2. I'm going to go ahead and write an interpretation for this. Okay, 25% of the scores in the distribution of data are below 4.2, which is the Q1, and 75% are above 4.2. So I'm not going to count it out, but there it is. That's the definition. Very similar to Q2, right? Except we're looking at a different percentile. So go ahead and take a look at that. And now we're going to move on to Q3. Okay, so now we're talking about the Q3, also known as the third quartile and the 75th percentile. So the equation to find the position of the Q3 is 0.75 multiplied by n. .75 multiplied by 28 is going to give you the 21st position. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the Q3 is going to be 6. Let me write an interpretation. Here you go. So very similar to the other ones, right? 75% of the scores in the distribution are below 6, 6 being the Q3, and 25% are above 6. So I want to make 2 more comments. The first comment has to do with percentile. Okay, so what if it said that you scored in the 80th percentile? Okay? That means 80% of the scores are worse than yours, 20% are better. Okay? Let's say that your baby is in the 56th percentile for weight. That means 56% of the babies are a lower weight than your child, and 44% are a higher weight. Okay? So I just wanted to make sure you understood that concept. And I also want to do one what-if scenario. So when the positions are even, like I think we had what? The 7th position and then the 21st position, that's really easy to figure out. But let's say hypothetically, now this is a hypothetical situation, let's say we had the 21st.8th position. Okay? If that was the case, so this being the 21st position, and this being the 22nd, that's not a good example. Let's say we had, let's go the 27th.8th. That's going to be a better example, because I think your activity is not as, let me rephrase that. It has decimals. Okay. Okay, so the 27th position is 6.2 and the 28th position is 7. Okay, so if the position of your Q3 was 27.8, it would be somewhere in between these numbers. So let's review how we do that. First, you have to find the difference between the two numbers. Okay, so we have to find the difference. So it's going to be 7 minus 6.2. The difference is going to be 0.8. Okay, so now you need to figure out what 0.8 of the difference is. So you're going to, I'm just going to write, you're going to multiply the decimal by the difference. In this case, they happen to be the same thing. So your decimal here is 0.8 multiplied by 0.8. So 0.8 multiplied by 0.8 should be 0.64. But I'm just going to verify that. Yeah, it's 0.64. So now what you do next is you take the lower position, which is 6.2 in this case, and then you add what you got in step 2. So it would be 6.2 plus 0.64. So in this case, your Q3 would be 6.84. Okay? So I just want to make sure that concept was clear. I know we did it with the median, but then the difference was 0, so that wasn't necessarily the best example. So I think this fabrication has kind of helped us understand the concept a little better. Okay, I'm going to go ahead and erase this, then we're going to move on to our next concept. Okay, our next concept is the mode. Okay, the mode is simply the value, well, it could be value or values that occur most frequently in a distribution of data. So let's see, which value or values occur the most? It's definitely not that one. This 3.8 occurs twice, 5 occurs twice, 5.2 twice, 5.4 twice, 5.6 twice, 5.8 3 times, so now 5.8 is the winner for now. 1, 2, 3, 4, 5. Well, 6 occurs 5 times. Okay, so the mode of the distribution is going to be 6. So here's an interpretation. The mode of the distribution of data is 6 because it occurs 5 times. Okay? If there were no duplicate numbers, that would mean every value occurs once. That would mean the mode is every single value. Right? Because every single value is tied at one occurrence. Okay, what's an outlier? Okay, value or values that are different from the rest in the distribution of data. They're either going to be very small or very large compared to the other scores. So that's the definition of outliers. Okay, so there's two different types of outliers. There's a lower outlier, right? So that would tell you which values seem to be too small, and then there's the upper value, which would tell you what values seem to be too big compared to the rest of the values in the distribution of data. So we know most of these components already. So let's go ahead and plug them in and solve these equations. What's the 25th percentile? Q1, which we found to be 4.2 minus 1.5, which is a constant, multiplied by the IQR. What? What's the IQR? Well, it's actually a measure of variability, but we need it to do this equation. So the IQR is simply the Q3 minus the Q1. So what's the Q3? It's going to be 6 minus the Q1, which is 4.2. So we have our IQR as 1.8. So there you go. IQR 1.8. So we'll just drop that number in there. So essentially, to find the lower outlier, we have 4.2 minus 1.5 multiplied by 1.8. So it's really important here to remember which you've probably heard of before. It's called order of operations, PEMDAS. Okay, what this is telling you is the order of operations, the order of you doing the math. You need to solve what's in the parentheses first, then you have to resolve the exponents, then you can multiply, divide, add, and subtract. Okay, so because we have parentheses here, it means you have to solve what's in the parentheses first. Okay, what some people might do, they might say, well, what if I do 4.2 minus 1.5, and then I'll multiply it by 1.8? No, that's wrong, because you're not following the order of operations. 1.5 multiplied by 1.8. Here, let me get my calculator. It's going to give you 2.7. So 4.2 minus 2.7 dropped it. Is going to give you 1.5. Okay, so what does that 1.5 mean? It means any values in the distribution that are 1.5 or lower are considered outliers. Look over here. Do we have any lower outliers? And the answer is yes, we do, because we have one value that is 1.5 or lower. In this case, it's the value of 1.4. So we do have one lower outlier. I'm going to go ahead and erase the IQR in the order of operations just so I can write down that interpretation. Okay, values in the distribution that are 1.5 or lower are considered lower outliers. And we have one. It is 1.4. Okay, cool. So let's go ahead and do the upper outlier. So the upper outlier is the 25th percentile, which is 6 plus 1.5 multiplied by the IQR. We found out that the IQR is 1.8. Okay, so let's do it. 1.5 multiplied by 1.8 is going to be 2.7. So 6 plus 2.7 is going to equal what? It's going to equal 8.7. Values in the distribution that are 8.7 or higher are considered upper outliers. Do we have any values in this distribution of data that are 8.7 or higher? And the answer is no. The highest possible value is 7. The highest value we have is 7. We do not have any. Well, hey, I think that works, right? There you go. Okay. Okay, so we talked about a whole bunch of concepts. Now we're going to do something super cool, something I really love. It's called the box plot. We're going to take all those concepts and we're going to put them all together. So I'm gonna go ahead and erase this. So the first thing you need to do when you're making a box plot is to create a number line. So start with the lowest possible value, which we know is 1, right? The lowest possible score someone could get on a satisfaction with life scale is 1. The highest is 7. So let's go ahead and do that by 0.1s, right? Because it looks, well, no, sorry, 0.2s. 0.1s would be a little too small. Because it looks like all the scores are separated by 0.2. So let's do that. I'm gonna try my hardest not to run out of room. 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, oops, 2.6, 2.8, 3, 3.2. Well, you know what I'm going to do, because I've just determined I am going to run out of space. We're actually, are we? We're actually done. We're done with these data on the board. So I'm going to go ahead and clear them off so we can have the entire board to make the box plot. That'll be a lot nicer. So we don't have to cram it. So again, I'm going to do my number line. Two, 2.2, 2.4, 2.6, 2.8, 3, 3.2, 3.4, 3.6, 3.8, 4, 4.2, 4.4, 4.6, 4.8, 5, 5.2, 5.4, 5.6, 5.8, 6, 6.2, 6.4, 6.6, 6.8, and 7. Okay. And let me try to make a straight line. It's pretty difficult on an 8-foot board. Okay, I'm going to make little dashes, approximately for each point. Okay, wow, the line's a bit crooked, but I think you get the point. Okay, so the cool thing about this, we can put all of our elements together. So the first thing we can put on here is our minimum value. So minimum value is easy, right? It's the smallest value we have in our distribution of 28 satisfaction with life scores. So the smallest value is going to be a 1.4. So min equals 1.4, and just write a little mark here, and you'll see, and yeah, Q1 is equal to 4.2, so we can write Q1 equals 4.2, Q2 is equal to 5.4, Q2 is equal to 5.4, and Q3 is equal to 6. Q3 is equal to 6. And then the maximum value is the highest score, or the highest value in our distribution of 28 satisfaction with life scores. Okay, so we're not done yet. We have to connect the lines in a certain way. So this is like a good start, so mark all these off like we just did. Between the min and the Q1, you just draw a line. Between the Q1 and the Q2, you draw a line on the top and on the bottom. Same thing from the Q2 to the Q3. And then from the Q3 to the max, boom. There you go. We could also go ahead and put our outlier fences on here. So let's go ahead and do that. Our lower outlier comes in at 1.5. So it's really nice graphically here. You could see that this score here, this one min score of 1.4, is an outlier because it's on the other side of that little dotted line. Oh wow, and then of course the upper outlier is a ridiculously high value. So what we'll do, I'm going to put two dashes or two lines through the x-axis here, but I'm just going to extend it all the way to 8.7, which is what our outlier is. Okay, so there's a couple of things that I want to talk about regarding the box plot. Let's talk about density, okay? And this is related to what we just talked about regarding percentiles. Okay, so we have between the min and the Q1, what percentage of the data do we have? Well, look at the Q1. The Q1's the 25th percentile, right? So 25% of the scores in the distribution are going to be below the Q1, 75% are going to be above. So 25% are below, 75% are above. That would mean the min to the Q1 contains 25% of the data in the distribution of satisfaction with life scores. Now the Q2 is the 50th percentile. 50% of the scores are below, 50% are above. Okay, so 50% are this way, but we already have 25% here. So 50% minus 25 means 25% of the scores are between the Q1 and the Q2. Okay? Now what about the Q3? It's the 75th percentile. 75% of the scores are lower than the Q3, 25% are higher. So we have 75% below the Q3. 75 minus 25 minus 25 gives you 25% of the data is between the Q2 and the Q3. Okay? And then again, Q3, 75th percentile, 75% of the scores are below, 25% are above, which gives us this 25% here. So that works out. That's great. One thing we did forget to do is we forgot to put in the mean. I believe we found the mean to be 5. So that's my bad, so don't forget to put in the mean. Usually with the mean, we just add a star. You could add a star and an arrow that says mean equals 5. So another way to talk about skew, right? We talked about skew in chapter 2 when we dealt with frequency. Another way to figure out skew is to look at the whiskers, if you will. These lines. Okay? So I'll write some rules for you. If the left whisker is longer than the right, I'll get rid of this then, that's a lot of thens. If the left whisker is longer than the right, the distribution is negatively skewed. If the right and left whiskers are equal, the distribution is normally distributed. If the right whisker is longer than the left, the distribution is positively skewed. Okay, so those are different ways of looking at skew. Okay, so this is the box plot. Now I'm going to go ahead and erase it, and I'm going to move on to a new concept, okay? Okay, let's say you were interested in figuring out what college income was. So the annual income for other students at the university. Okay? Let's say you were walking around campus and you ran into 7 different people and you asked each of those people what their annual income was. And maybe the first person said $5,000, the second person said $6,000 a year, the third person said $10,000 a year, the fourth person said $11,000 per year, the fifth said $20,000 per year, the sixth said $45,000, and the seventh said $1 billion a year. I suppose maybe you ran into an entrepreneur that was giving a talk or accepting an award on campus. Let's just say that. So go ahead and do 2 things for me with these data. I need you to calculate the mean as well as the Q2. So go ahead and do that. And I will write up the answers that I got. The Q2, or the median, I got $11,000. Well, pretty easy, right? For the median. Order the values from smallest to largest. Okay? And essentially, if you calculate the position, it would ask for the 4th position as the median, which is 11,000. And then the mean is going to be $142,871,000. Okay. So remember the big picture here. When we're talking about central tendency, we want to tell the world or our manager or the research community, whoever, we want to tell them what value is typical in the distribution of data. Okay? Okay. 142 million. Does that represent this distribution well? I'm going to say no, because most of the scores aren't even above 50,000. So we look at the median, 11,000. Does that do a better job of representing our distribution? And I'm going to say yes. So the problem here is the mean is impacted greatly by outliers. This $1 billion in this distribution of student annual incomes is a huge outlier, and it's messing with our measure of central tendency. Because typically, people would just report the average, right? But the average is terrible. Okay, most students do not make $142 million a year. Okay? So that 11,000 is more representative. So the lesson here is always look at the mean and the median. Sometimes the median is going to better represent your data than the mean. Let's draw this as a picture, just to drive the point home. Now, if we graph this on a curve, lower scores here, so there's a lot more lower scores, right? And then higher scores over here. The median would be about here, and the mean would be here. So what's going on here is the mean is highly impacted by these outliers, these rather large or rather small scores. So as you can see, the mean is being dragged all the way to the right by this $1 billion a year. So this has other important implications for identifying skew. So this is our third way to identify skew. Okay, the first way, we looked at, well, when we do frequency, what direction is the tail pointing? Is it pointing to the left, pointing to the right, equally pointing to the left or the right? And then we just saw in the box plot, we could do the same thing with the whiskers. Here's another method. Okay, here we go. Positive skew. This is positively skewed. We could tell because the tail is pointing to the right, okay? But another way is we can say this. If the mean is larger than the median, then the distribution is positively skewed. Let's look at what negatively skewed looks like. So in this case, you notice the tail's pointing to the left because there's some extremely low score over here that's pulling the mean. So remember, the mean is highly reactive. If the mean is smaller than the median, it's negatively skewed. And for the last one, oh, my green pen died. Okay. So then if the mean and median are equal, the distribution is normally distributed. Okay, great. So that's all I have for you on central tendency. Be sure to send me an email if you have any questions, okay? I love answering questions. I'm super thankful that you all are interacting with me already. You know, it's just the first week, and you're sending me questions. I love to answer them. As you can see, if you need me to make a video to explain something, I'll do it. Okay, let's go ahead and pray. Dear Heavenly Father, thank you so much for blessing us. We are so blessed, both the students that they're able to take these classes, to learn about statistics. There's people who have no idea about how to organize data or make statements based on data. And it's just so important, Lord. Thank you, Lord. Just give them the wisdom to see how this class is connected to the plan that you have for them. Lord, thank you for blessing me with this opportunity to be here with these students, even at this long distance, to teach them, to have the technology to do this. You are amazing. Lord, give us the wisdom to let your light shine through us every day. Thank you very much, class.